The Giants Causeway. Okay, so we're starting off with the most famous one on the list, and arguably one of the most famous geological formations of anywhere in the world, to be honest. The Giants Causeway is located in the north of County Antrim, in Northern Ireland, and consists of over 40,000, mostly hexagonal-shaped basalt columns. So they formed between 57 and 68 million years ago, when a series of fissures opened up, pouring out lava that's in some places over 2,000 metres thick. The formation was part of a series of rifts associated with the seafloor spreading of the early Atlantic Ocean. As the basalt solidified, the centre of the molten mass cooled much slower than the exterior of it. One was formed as the rock fractured internally due to the thermal contraction as the rock was cooling. The exterior of the lava contained much more air, and thus when it solidified it contained more vesicles, and thus made it much more susceptible to erosion. So over time this area has actually been eroded away, exposing the interior basalt columns from this old lava flow. The Giants Causeway is one of the most popular attractions in Northern Ireland, and pre-COVID times was having roughly 1 million visitors a year, and because of its special and unique nature, as well as the extent of the basalt pavement that is available for viewing for the public, the area was made a UNESCO World Heritage Site in 1986. The Welsh Borderland Fault System. In central Wales and in the border county of Shropshire, there is a complex series of faults and folds that make up an area known as the Welsh Borderland Fault System. Now, a lot of these faults and foldings were formed during an episode of mountain building known as the Caledonian Orogeny, which took place between around 490 and 390 million years ago, as the supercontinent of Pangaea was starting to coalesce. Now, the complex nature of these faults led it to be extensively studied by a number of early geologists, in particular Roger Mackesson, Adam Sedgwick and Charles Lapworth. Collectively, their work extended our knowledge of the Paleozoic, and it led to the realisation that actually this was a much more complex and much more extensive period of time, and that actually 3 of the geological time periods within the geological time frame that we still use to this day are named from the Welsh Borderland Fault System. The Cambrian period, which is named after Cambria, an old Latinised version of the Welsh word for Wales, Cymru, and the Ordovician and Silurian periods were named after Iron Age tribes that inhabited the area before the Roman invasion, the Ordovicii and the Silurii, respectively. Even many of the subdivisions within these time periods are named after places within the Welsh Borderland Fault System, in particular Tremadog, Llandovery, Ludlow and Wenlock. The Ironbridge Gorge. At the north end of the Welsh Borderland Fault System is the Ironbridge Gorge. Now, the gorge itself was formed during the last glacial period between 115,000 and 16,000 years ago. As the ice advanced through Cheshire and Shropshire, it diverted the course of the River Severn, pushing it underneath the ice flow and forcing it to flow southwards instead of northwards. The River Severn eventually butted up against the north end of the Wenlock Edge, an escarpment of limestone, and eventually managed to cut its way through the limestone and then through the much softer carboniferous rocks behind it. Now, in the process of this happening, it exposed layers of ironstone and, in particular, coal. Now, all 3 of these ingredients were present to have a thriving iron industry. You got the coal, the iron ore for the ironstone, and you got the limestone that you need as a flux to help purify your iron material. Plus, you also have the river itself that would allow easy transportation to a much wider market. Now, using all these materials, a man called Abraham Darby established an ironworks there in 1708 and started to produce pig iron using a blast furnace. And although he didn't necessarily invent the procedure, what he did start to do was pioneer of the mass use of coke, a type of coal, in his use for the production of iron, as opposed to using charcoal, which is what had been used for centuries. And in 1781, his grandson, Abraham Darby III, would use this revolutionary technique to make the world's first bridge completely out of iron, from which the gorge now gets its name. Because of its significance to the Industrial Revolution and how it shaped the modern world, the Ironbridge Gorge was granted UNESCO World Heritage status in 1986. Rannoch Moor. Okay, situated in the Scottish Highlands to the southeast of Fort William is Rannoch Moor, a large expanse of upland moor and peat bog covering roughly 130 square kilometres. The area is one of Britain's most wonderful wilderness expanses. It's a great home for wildlife and has also been the filming site of a number of TV shows and movies. Perhaps most famously, one of the valleys leading off Rannoch Moor, Glen Etive, was used in the James Bond film Skyfall. Another spectacular valley coming off Rannoch Moor is the perhaps more infamous, at least as far as Highland history is concerned, Glencoe, where in 1692 the Glencoe massacre led to the murder of over 30 members of Clan MacDonald by the Scottish Government forces. Aside from the historical note, one of the key things that makes Rannoch Moor special within the British Isles is it's actually at this spot that the last ice sheet within the British Isles finally met its end. Now, the ice had been melting in the last glacial period for several thousand years. In fact, the ice had its extent had gone as far to the south as Shropshire. But it was here, around about 11,000 years ago, that the ice finally disappeared from the British Isles. The ice itself has left this wonderful hummocky landscape. There's plenty of moraines around. There's some eskers as well as the hummocks, and obviously a very peaty and boggy landscape with a lot of water, surface water as well. Some wonderful glacial valleys coming off it, in particular the aforementioned Glen Etive and Glencoe. You can see these wonderful deep U-shaped valleys where the glacial ice at one point had cut away the rock as it expanded away from the ice cap. The flow country. So going on to another peat bog, and this time it is in the very far north of Scotland. Now, covering over 4,000 square kilometres, the flow country is the largest area of blanket bog anywhere in Europe. It formed after the ice retreated, so it's been working its way to its current state over about 11,000 years. And in some places the peat is over 10 metres thick before you get down to the bedrock. Peat bog is a relatively rare habitat within not just Europe but the world as a large. It can only form within wet and relatively cool and cold landscapes, so you'll find a lot of peat bog in places like Canada and Russia and Patagonia. The flow country itself represents about 1.5% of the blanket peat bog in the world. Now, despite the desolate look of this environment, there are high levels of biodiversity here. Plants and insects particularly love this kind of environment, although they do have to have some very specific tolerances. These sphagnum mosses, combined with the metamorphic and silicon-rich igneous bedrock, have led to a very acidic environment, so any kind of plants that live here have to have very specific tolerances towards a very acid soil. You don't get that plant decomposition that you normally get in another environment. Now, this allows the peat to build up over the millennia rather than the plant material fully and properly decaying as it would normally do somewhere else. Now, in the light of modern concerns about climate change and the concept of carbon traps, these kind of environments do provide a very valuable natural way of helping to store a lot of carbon as it's taken out of the atmosphere into the plant material and then doesn't get re-released unless we burn the peat. And for its environmental significance, both past and present, the flow country is currently on the tentative list trying to achieve UNESCO World Heritage status. Malham Cove. Located in the Yorkshire Dales, Malham Cove, despite its name, is nowhere near the sea. The limestone pavements in the area are, for the Carboniferous period, between roughly 331 and 337 million years ago. During the last mass glaciation, the ice sheets in the area scraped off the soil and a lot of the softer surface rock from the Yorkshire Dales. Now, what this left you with is this relatively bare, open landscape where there's a lot of limestone rock exposed, hence the limestone pavements. And as these glaciers melted away, the glacial meltwater obviously eroded a river channel out, and this channel eventually went over the escarpment that is now Malham Cove in a spectacular waterfall and started to erode the cove back, creating this absolutely gorgeous horseshoe shape. Now, what would have been the cataract at Malham Cove is about 80 metres high, and its widest would have been about 300 metres across. And to put that into comparison, the Horseshoe Falls at Niagara, which is the largest, the Niagara complex, is 51 metres high. So Malham's considerably higher than Niagara, but would have been about 820 metres across. So this would have been a spectacular waterfall at this time. Now, limestone is a porous rock, and we know there is a cave complex behind the waterfall and underneath into the limestone pavements. The reason the rivers were able to erode the limestone during the last glaciation is partly because of the sheer volume of water, but the other significant part of it was that this area was still a periglacial environment as the ice is retreating, so there's still a lot of permafrost in the area, so it meant that the limestone was actually semi-frozen and would have been impermeable to the water, hence why it was able to erode it back. Now, the cave complex has been partially explored. We don't know the full extent of it, but we do know that it extends back at least 1.6 kilometres. So we've got quite a substantial network in there. Creswell Crags. On the border between Nottinghamshire and Derbyshire is this small gorge called Creswell Crags. Now, the rock itself is dolostone and is around 252 to 272 million years old. But that's not why I've included this on this list. Creswell Crags is one of the most significant areas for the finds of Pleistocene animals of anywhere within the British Isles. Now, there are several dozen caves in the area, many of which are large enough for inhabitation, and the remains of animals such as hippopotamus, hyena, woolly rhino, woolly mammoth, bison, lions, bears, reindeer, red deer and horses have all been found within the area around Creswell Crags, either in the caves or in the valley between them. We've also found the remains of tools from ancient humans, both ancient Homo sapiens and Neanderthals. Now, the Neanderthals were in the crags from at least 58,000 years ago, as we found the tools dating in sediments roughly from that period of time. So that Homo sapiens have been in the area from around about 15,000 years ago. For how it's improved our understanding of Pleistocene Britain, as well as Pleistocene Europe as a whole, and the animals that lived inside it, the Creswell Crags was added to the tentative list for the UNESCO World Heritage Status in 2012. The Cuckfield Dinosaurs. Now, Cuckfield is a small village located in rural West Sussex. Now, there's sadly not a lot here to see anymore, as there used to be a quarry, but it has been largely filled in and replaced with a sports field just on the outskirts of the village. In the early 1800s, this area was one of the favourite fossil hunting places of a man known as Gideon Mansell. Now, Gideon Mansell was arguably the world's first dinosaur hunter. The man was a medical doctor by profession, but had a passion for geology and particular paleontology, and was one of the most prolific fossil collectors in the south of England. He used to use Cuckfield Quarry as one of his favourite collecting places, and he actually found the remains of several species of dinosaur there, including Regnosaurus, Hylaeosaurus, Cuckfieldia, Pelorosaurus, Voloraptor, and most famously Iguanodon. And it was two of his finds, Iguanodon and Hylaeosaurus, that were used by Richard Owen in 1842 to define Dinosauria as a distinct group of reptiles. The rock itself is Cretaceous age. It's from around 134 to 139 million years ago, and aside from the dinosaurs, he also found the remains of a wide variety of plants and other animals that helped distinguish this area as a river system rather than what had previously been thought of as the bottom of a seabed. So by extension, he also helped our understanding of geology and how sedimentary formations develop within the environment. It was this man's absolute love and passion and dedication towards paleontology that helped kickstart the science of dinosaur paleontology. The Cornubian Batholith. Underlying much of Devon and Cornwall is the Cornubian Batholith. Now, this is a large mass of granite that formed between 310 and 275 million years ago at the end of a period of mountain building known as the Variscan orogeny. Now, how this formed was as the magma moved up through the crust, it melted away part of the crust, but it never actually quite breached the surface. And this allows it to cool over a long period of time, as it isn't exposed to water or the air, so it's not going to cool particularly quickly. So you end up with wonderful large crystals that you find in granite deposits. Now, later erosion took away a lot of the softer areas, so you end up with a lot of granite exposed in places like Dartmoor and Bodmin Moor, Land's End and the Scilly Isles. Aside from the rugged beauty of this landscape, the real significance comes in what that molten rock brought with it, and that was a series of metals, in particular copper, lead, zinc, tungsten and especially tin. To make bronze, you need copper, and you need about 90% copper, and you need a small trace of some other metal. Now, they did use things like arsenic, which does create a nice bronze, but arsenic is also quite toxic. So the preferred material is tin. Now, copper itself is actually relatively common, But tin is comparatively rare, not just in Europe, but globally. It is not as well found as something like copper. Bear in mind that Bronze Age culture is really kicking off in what's now the Middle East, the Eastern Mediterranean, and stretching out to the Indus Valley in what's now modern-day Pakistan. And it was basically where they sourced a lot of their tin from. And really, in Europe and the Middle East, there are only two decent sources of tin. There's a series of mountains on the German-Czech border, and Cornwall. Now we know that tin and copper mining within Cornwall started at least as early as 4,000 years ago, and this tin has been traced through metallurgical analysis to bronze artefacts throughout the Mediterranean and the Middle East, so we know that Cornwall was connected to a massive Bronze Age trade network. Now later on in the Industrial Revolution, Cornwall continued to provide a lot of copper and a lot of tin for the global demand, and at one point in the early 1800s, Cornwall was producing roughly half the world's copper supply. The depths of the mines they were going to extract this copper ore and the tin ore, along with the fact that a lot of these mines ended up going under the sea, it meant that a lot of these mines were getting flooded by the groundwater. To extract the groundwater, started off with manual pumps, but eventually they started to pioneer the use of steam pumps. And this development of steam technology also helped to fuel and develop the ongoing Industrial Revolution. After World War II, the increased use of aluminium and plastics for a lot of packaging material led to a drop in demand for tin, and eventually the last tin mine closed in 1993. Now, for its significance not just in the Bronze Age but also the Industrial Revolution, the Cornish and Devonshire mining landscape was added to the UNESCO World Heritage List in 2006. Siccar Point. Located roughly 50 kilometres east of Edinburgh along the coast is Siccar Point. And there are few places that are as significant as Siccar Point when it comes to the development of our understanding of Earth's history. In June 1788, a man named James Hutton, one of the founders of geology, was on an expedition with a colleague called John Playfair when they noticed a particular formation along the cliff face. At the base of this formation is a dark grey sandstone known as a grey wacky. The beds of this grey wacky weren't horizontal, they were nearly vertical, and they'd also been eroded off along the top. And then on top of that are near horizontal layers of a red sandstone. Now Hutton realised that this meant that the two deposits couldn't have been laying down at the same time. There must have been a significant time gap between the laying down of the grey wacky and the deposition of the red sandstones. What it meant is that the grey wacky must have been deposited, and because of gravity it would have been deposited roughly horizontally. It must have had time to harden into rock, so it's no longer just loose sand. It would have been folded and bent so that it was vertical. It would need to have had time to have eroded away at the top for a primitive soil of some description to have been laid down as part of all that eroded material, and for then the red sandstone to have been laid on top of that. And this is something that wouldn't have happened over a short period of time. We're talking an extensive period of time that this would have taken place. Now this led Hutton to realise that the Earth was a lot older than the 6,000 to 10,000 years of the Genesis narrative that was told in the Old Testament, which was one of the prevailing ideas within the scientific community in the late 1600s and into the 1700s. Now from this, Hutton helped develop the concepts of a really old Earth, and it really kind of laid a lot of the foundation for the beginnings of our understanding of geology as a science, its processes, and how the Earth operates, really. With continued study and with better techniques that we've developed over the years, we now know that the grey wacky at Siccar Point was deposited at the bottom of an ancient ocean called the Iaptus Ocean, around about 435 million years ago during the Silurian period. We then had the Caledonian orogeny, and it was this period of mountain building in which the rock was buckled and bent, partially fractured, and was brought up above the sea level as the Iaptus Ocean closed. It was exposed to weathering and erosion, which is where you get that deposit of looser material on top of that. And then around 370 million years ago, towards the end of the Devonian period, a series of seasonal rivers in a very dry and arid environment started to lay down these layers of sandstone that were coated in iron oxide and blown around by the wind, forming sand dunes, as regularly happens in dry and arid environments. And this formed the top layers of the sandstone. And this gap in between these two layers is known as an unconformity. at Siccar Point, it's one of the examples of what became known as Hutton's Great Unconformity, where he realised that actually there are time gaps, that you're not getting a continuous progression in your rock record, that there are times where there are pieces missing. So that's 10 interesting geological and geographical places within the British Isles. Now, I know anybody watching this is probably thinking you've missed out a lot of places. I was in particular loath that I had to drop the Dorset coast, but I do plan on doing more of these. I plan on looking perhaps not just at the UK, but also looking at some of the other geological places around the world.